Okay guys, unfortunately I don't have the right adapter, so I can't do a whole lot of writing on this, but I'm going to try to go through it and give you the key points of this lesson. So this is 9.2. It's like measure of arcs. We're going to identify central angles, major arcs, minor arcs, semicircles, and then find their measures and find arc lengths. So our vocab: central angle, arc, minor arc, major arc, semicircle, congruent arcs, adjacent arcs, arc length. We're actually not going to talk about radian measure. Let me go back and, well, no, we'll just go through it as we get to it. So sum of central angles. This is just saying, so this is a central angle, 2 is a central angle, and 3 is a central angle. This is just saying that the sum of all the central angles within a circle is going to be equal to 360 degrees. So on this screen where it says find the value of x, we're going to look and see what we know. We know we have a diameter right here. So that means this is 180 degrees. So what we can do is we can set 8x minus 4 plus 13x minus 3 plus 5x plus 5 equal to 180, and then go ahead and solve for x. I'm going to let the slideshow do it right here. And then they combine their like terms, get 26x minus 2 equals 180. Go ahead and solve, and x equals 7. This one is done similarly. You can go ahead and try it on your own if you want. I'm going to just click the answer. Okay, so arcs are the parts of the circle. And a minor arc is the short length. Whoopsies, I went too far. The major arc is the large length, and a semicircle is the 180 degrees, half of the circle. So when you are naming a minor arc, you only need 2 points. So note the notation here: measure of arc AB. Okay, and that measure is equal to the measure of the angle. So the central angle ABC, or ACB, sorry. So if this central angle was 100 degrees, the arc length would also be 100 degrees. Okay? A major arc is named by 3 points. You have to use 3 points, otherwise it's assumed to be the shortest. So this is measure of arc ADB would be whatever degree measure of this angle is. And then a semicircle is like, it's always better to use 3 points to name if at all possible. Otherwise you don't know which side of the circle they're talking about. Okay, so this is just classifying as whether it's a major arc, minor arc, or semicircle, and then find its measure. Well, they want arc x, z, y, so that's this side right here, and it's a semicircle, so it's going to be 180 degrees. Arc w, z, x, so w, z, x goes this way, so we have 3/4 of the circle, which is 270 degrees, and that is a major arc. And then they have arc XW, which is just this part right here. And as you can see, this is a 90-degree central angle. Therefore, the minor arc, did I say minor? I don't know. The minor arc is going to be 90 degrees. All right. This is just some examples for you to try if you want, but I don't think this part's too difficult. Okay, so this says in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. So you can see if the central angle 1 and central angle 2 are congruent, then we know that the arcs FG and HJ are also congruent. And vice versa. If the arcs are congruent, then the angles are congruent. So this I'm going to try to probably write on here if I can. It says, refer to the circle graph and find measure of arc KL, which is this right here. Okay, so this is 21%, not 21 degrees, but 21%. And we can find out how many degrees it is because we know a whole circle is 360 degrees. So we know that 21%, that's a 21% of 360. So you're just, oh, this is, there we go. So you're going to take 0.21 times 360, and then you're going to have the number of degrees that is. Maybe I should just let the PowerPoint do it. So 0.21 times 360, 75.6. So the measure of arc KL is 75.6. Here's one, measure of arc NJL. So that's going all the way around. Okay, so a couple different ways. You could add these up and then multiply that percent times 360, or you could subtract it, however you want to do it. I think they do the subtracting thing, which doesn't, that seems like just an extra step to me, but whatever you want to do. So they did each one. Oh, they did each one separately. Oh, you don't have to do that. You can just add them all up right away and then multiply that percent by 360. Either way, you should end up with 302.4. Now, that makes sense because that's degrees. The measure of that arc is degrees, 302.4 degrees. It's going to be less than 360, and if you look at it, it's going to be more than 270. So that's pretty decent estimation there. Here's another one. I'll just click it. You can always pause these and do them. This one says the arc addition postulate is just saying that if you have two arcs, like arc XY and arc YZ, then that's going to be equal to arc XYZ this way. So the two parts equal the sum of the whole. So measure of arc LHI. So right here. I can honestly do this just at first glance here because we know this is 90 degrees. This is a diameter, so this must also be 90 degrees. So we don't even have to do any calculations with that. Okay, this they want you to find IJK. That's this much. So we know that HIJK, like that, is 180. So we just need to take 180 minus 32 to get the measure of arc IJK. And they do it probably a little differently than I do. So go ahead and try and do this one, and I'll click it. And this one. All right, this is the one that I really want you to know. The other things are kind of easy to get, but this is the arc length. And there's a couple different ways they show you that you can find the arc length. And what we're going to do is use the circumference. So if we know the radius, we can find the circumference, and to find the arc length, we just have to use that fraction or that ratio of the circumference. So they use this proportion. I actually usually go with the equation. They're the same thing, but to me this is just easier to memorize, I guess, because it makes sense. Because the 2 pi r, that's just your circumference, okay, or pi times diameter. And then this is the portion of the degree over the 360. So this makes the most sense to me. Okay, so find the length of arc DA. Okay, so we know that the radius is 4.5 centimeters. So that means the circumference is going to be 9 pi. And then to find just this portion here. So this whole thing, this whole circumference is 9 pi. But we just want this portion. So we're going to take this and multiply it by 40, if I can get the pen to work. Okay. 40 over 360. That is terrible. But yes, you take 40 over 360 and multiply it by 9 pi, and then that's how you get just this portion of the circumference, so this arc length. Okay. They got 3.14. I didn't type it into the calculator. Another one, so DA would be this part right here. So we know the radius is 6 centimeters, so we know that the diameter is 12 pi. And we're going to multiply it by, and it doesn't matter which side you multiply on, 140 over 360. It's always going to be over 360 because that's the number of degrees in a circle. So when they go ahead and do that, they get 14.66 centimeters. This is using Radian Measure, and we are not going to talk about Radian Measure. If there's one in your assignment, just skip it. We'll actually talk about that a lot more next year. It's just a different way to measure instead of degrees. Okay, so here's a couple you can try. Okay, I will have the assignment posted to Google Classroom because I don't know what it is offhand. Good luck, and if you have any questions, I will answer them on Thursday because Wednesday we have an early out, so I won't be seeing you. Good luck.